Today, I will be presenting you our senior year project, integrating top-down knowledge with bottom-up experience using large language models. And the advisor of the project is Emre. First, let me start with the definition and the motivation. Our general purpose is to integrate top-down knowledge using large language models into ongoing research about a novel deep neural architecture for signal formation and rule extraction, Alpha methods deep sim. The integration of large language models into robotics research has the potential to create a revolution in the way robots interact with humans and their environments. Let me briefly talk about deep sim. You can see the general process from the right. The methodology of the proposed approach in deep sim utilizes deep learning techniques to build symbolic representations of robots' environments and learn rules for planning actions based on these representations. The paper describes several experiments in which the proposed approach is used to plan and execute complex manipulation tasks in a simulated environment. Before we started our work, we first scanned the literature. A true literature review is essential to our project, as it provides a comprehensive understanding of existing research, identifies knowledge gaps, and help us navigate a clear path toward achieving our objectives. With Seiken. The paper Seiken explores the importance of connecting language instructions with the physical capabilities and affordance of robots to improve their understanding and execution of tasks. And then we have grounded decoding. The paper introduces a method that combines grounded models of robot control with text generation, enabling a more accurate and textually appropriate generation of textual instructions for robots. Now let me talk about our progress throughout the semester. To comprehend the outcomes and capabilities of the LLMs, we first defined a network that takes hidden states of the large language model, OPT, for sentences as input and tries to classify them in order to do objects in sentences, which is a binary classification problem. Our inputs are basic sentences, which includes an object which is rollable or non-rollable. For example, there is a ball on the table, and another example is one can find the cube position on the table. First sentence includes the word for rollable, ball for rollable, and cube. The second sentence includes a non-rollable word, which is cube. And here we can see our statistics. During the project, we had lots of challenges. First and foremost, since our topic is relatively new in the research field, it was quite difficult to find resources to guide us. Because of that, it took longer to get into the project than we had planned. And also, we had problems in decision-making progress. Especially at the beginning of the project, we were not successful enough in making effective decisions because there were multiple routes we could take. This caused us to spend more time than necessary in deciding on the method we will use. Other than these challenges, we had problems related to hardware. The large language models we want to use require lots of RAM because they have too many parameters, billions of parameters, and our personal computers couldn't meet this need. The online resources we decided to use afterwards, such as Google Colab, were also insufficient to meet this need as the number of data increased. So this semester we did this, and for the future, we first plan to, rather than only one action, some other actions will be included to connect the robotic with robotic affordances. For example, we plan to add push left or right, pick and place. Secondly, we want to create a more generic method. And third, for now, we represent our effects in binary classes. But in future, we, of course, want to change them into verbal classes. Like instead of zeros and ones, we plan to give sentences, not numbers. For the fourth step, when the language processing is done, if the results are promising, our final goal is to connect our model to the DeepSim architecture we mentioned in the first place. If you want to contact us, you can reach us from these email addresses. And thank you.